recent study conducted by Hospitality Technology revealed that the #1 challenge faced by hotel IT administrators was meeting high guest expectations for technology advancements. Other challenges include limited IT budgets and the lack of IT talent needed to make the necessary improvements. Enhancing the wireless network infrastructure to provide reliable connectivity for your guests' mobile devices is the first and probably the most impactful step to improving guest satisfaction in regards to your technology initiatives. Hi, I'm Daniel, Field Engineer for Ingenious Technologies, and today I'll be talking to you about the proper placement of dual-band wireless access points in hotels. Typically, the owners want to place the access points in the hallways, but having them in the rooms is better when it comes to performance. But be realistic. Many times having APs in hallways is part of the requirement, whether you like it or not. Even though it is entirely true that the overall network performance will be affected, you need to do it anyway. Having APs in the hallways are typically better protected against guest tampering, easier to gain access for maintenance, and installation costs are lower. Typical distance between APs is about 50 to 60 feet, but doing an initial site survey by temporarily installing a few access points can save you both time and money as the installation progresses. Consider the aesthetics of the access point and consider the non-intrusive smoke detector style indoor APs. Also consider the physical security of the APs by placing them in higher, harder to reach spots. If you're providing coverage to outdoor areas such as swimming pools or courtyards, you will probably need to use IP-rated outdoor APs. Common areas and fitness rooms can be high-density locations. You may want to install one or more APs specifically in those areas, with the power set much lower. Ethernet and PoE distance limitations is 328 feet. PoE switches need to be in the MDF and, depending on the size of the property, in one or more IDFs in a safe, secure, and temperature-stable area. Divide up the connection points to reduce the number of single points of failure, and use UPSs to provide protection and to provide backup power. 2.4 GHz has only 3 non-overlapping channels, which are channels 1, 6, and 11, assuming you're setting channel bandwidth to 20 MHz. Setting channel bandwidth to 40 MHz or 20/40 MHz is not recommended. Channel width settings must be set to 20 MHz only to have 3 non-overlapping channels on 2.4 GHz. Now for 5 GHz, it has 12 non-overlapping channels, so avoiding co-channel interference is much easier. Placement is very important to reduce the negative effects of co-channel interference. When placing APs, you must consider 3D, not just along the horizontal plane, but above and below as well. If 802.11ac APs are used, it is not recommended to set to 80 MHz because of the amount of interference it can cause and the reduced amount of available channels. Now let's talk about power. Power of client devices is typically very low. Power of the AP must be similar to the devices connected so coverage is symmetrical and for roaming to work properly. Do not set RF power levels higher than 20 dBm for 2.4 GHz or 5 GHz in most cases, and set 5 GHz 3 to 5 dB higher than 2.4 GHz so coverage matches more closely to 2.4 GHz because 5 GHz doesn't go as far. Don't just blindly turn up power all the way. Thank you for joining Ingenious Tech Talk. Be sure and check out our other Tech Talk videos.